And you have to calculate it too, because all these manuals you have to calculate it. So this is where knowing your technique helps. Okay, and then we have an automatic radiography. It's not simple. When you do a shoulder, just look at the shoulder, side view, press that, and then it just automatically goes to the different selections. So, and then this difference by the side. Oh, it's a kid. She's a kid. The chances is KV and oh, it's big, scary guys. So here's the exposure. It has two legs for buttons and exposure switch for some weird reason. The exposure switch here, you press it down half down. It's a prep, so it stop the rotor. And when the exposure, press it all the way down. Same concept here. Just press down, then press that over to the exposure. And then we have our KV, MA time selections. Here's the ones that's digital touchscreen. This is what I use in the county jail. Where KV, MA, math, and second. MA and seconds give the product of math. So this is what we're looking at when we make our technique. KV and math. And then we have different body size, kid, large. In gel, it's always large. There's no kid, just large. Even the female put large. The female's scary too. Actually, the female is more scary than the guy. Hi. Oh. So scary. Want to be my date? No? Okay. Now the X-ray circuit have two main areas, or two major areas. One is called the main circuit, and the other called the filament circuit. The main circuit can also be called the X-ray tube circuit. The purpose of the main circuit is to supply power to the X-ray tube to produce X-ray energy.
Can you repeat that?
The purpose of the main circuit is to supply power to the X-ray tube to produce X-rays. That's why it's also referred as X-ray tube circuit. Supply power to the X-ray tube to produce X-ray energy. The main circuit can be subdivided into two different areas. One is called primary circuit and the other called secondary circuit. I think I'm going to use handout. I forgot to change this. I put down like areas, right? Three major.
You put areas, yeah.
Change it. The primary circuit is a part of the side that have low voltage that is coming in. It begins with the auto transformers. The secondary circuit would be the area that there's high voltage, so it's a high voltage area. And within the secondary circuit, that's where you find the rectifiers components and ending at the X-ray tube. And then the other part of the circuit is the filament circuit. The purpose of the filament circuit is to supply power to the filament wire of the X-ray tube so that thermonic emission can occur.
Can you repeat that?
The purpose of the filament circuit is to supply power to the filament so that thermonic emission can occur.
Did you say you wanted us to copy down that picture?
No, it's fine, because you have other pictures that I have. That's not enough. Okay, let's talk about the filament circuit first. The major parts of the filament circuits, since it's supply control current, that's where the MA selector's component is located. The purpose of the MA selector is allow, when you change your MA selections, it moves a needle device, or whatever it is inside, to the appropriate current scale. So it has an electronic device called rheostat. A rheostat is pretty much a variable resistor, so it can fluctuate based on your MA selection. It adjusts the resistance to vary the amount of current flowing through the filament based on your MA selection. In the filament circuit, there are also what's called the focus spot selector. In the X-ray tube, there's usually two different filament size. One's large and one's small, depending what body parts or how much current needed. If there's low current, then you can use small filament. If it's large current, then you can use the bigger filament. So the purpose of the focus spot selector allow the current to flow through on different type of filament wires based on your current selections, MA selection. So there's a tap that moves to different directions based on what technique you use. And of course, the filament circuit has a step-down transformer, which is responsible for changing and regulating current based on your, again, MA selection. Step-down transformer, also known as filament transformer, which is located in the filament circuit. And they connect directly to the filament of the X-ray tube to help generate thermal emission. In order for thermal emission to occur, current at least has to be at least 3 amps for that to occur. So it fluctuates. Just a diagram with the filament transformer. So again, the line comes in, which make sure that consists of 240 volts coming in and going through the R transformer. The R transformer can deliver those electricity to the high volt transformer and the filament transformer. When you make your MS selections, the knobs will select the different MS stations, which then deliver to the X-ray tube at the filament. Here's the R transformer. We have a major KVP selection, minor KVP selections. And this, what's a zigzag line in the electronic components? It's a resistor, right? So it has this variable resistor. So this is a rheostat right here. So it's your MA selection. We have a focal spot selector, large or small, depending what MA selections you make. The emitter selector and focus box are usually located in the primary portion of the step-down transformer or the filament transformer. Transformer. Kind of different diagram, but the concept is the same. It begins with the R transformer, which allows technologists to make technique selections. More diagram, the same. Okay, R transformers operate on the principle of self-induction, meaning it's only have one coil of wire that acts as both as primary and secondary. The R transformer allows the technologists to change the kV selection. When you changing out kV technique, the R transformer needs different tabs to help you do that. So have you changed kV? So it regulates pretty much the kilovolt. Okay, so kV, kilovolt potential control. The primary function of it on a control console is to determine the penetration power of the beam based on the anatomy that you're focusing on. So the quality of the beam. In terms of when you talk about the X-ray imaging film, kV determines the radiographic contrast of the image. That's the differences in terms of black and white on X-ray film, or the scale of it. On the imaging system, there's usually a meter that's built in to regulate to determine how much kV is going through. This meter, or kV meter, is usually put on the primary side of the high voltage transformer. This is the diagram. So we have a voltmeter here. And sometimes we also refer as a pre-kV meter because on the primary side it's low voltage. So everything only is coming as volt. As it comes to the other side, it become kV. But we'll call kV meter because the end result is kV coming out. So it's located on the primary side of the high voltage transformer. Other way of saying it, because on the test, the national test, they have different answers in terms of determining where the location is, based on perspective. The voltmeter, kV meter, can also be said is located on the primary circuit of the X-ray tube circuit or main circuit. The kV meter is located between the R transformer and the step-up transformer, because HVT is a step-up transformer. So there's different ways of saying where it's located.
So it's in the primary circuit or the primary?
primary circuit on the primary side of the high voltage transformer, in between the R transformer and the step-up transformer, in between the R transformer, the high voltage transformer, just how you see this.
I can't make that.
One location, same place, different variation in answers. Because on the national test, I don't know what kind of answer they give you. So I'm giving you all possible scenarios. And those are usually the main different scenarios. Okay, milliampere, what does it control? The purpose of an A station is to determine the number of the electrons boil off from the filament. So it's, again, it's quantity, the amount of electrons coming out. And in terms of the X-ray film, the number of X-ray reaching the film determines the degree of blackness on the film. So it determines the overall darkness of the entire X-ray film. How dark it is, how light it is. Too much MA can overexpose, so the X-ray film will completely black or really black, dark. Too little of MA also make the X-ray film really light. And again, there's a meter that also determines how much MA flow through at one point. That's built into the X-ray imaging system, and this MA meter is located on the secondary side of the high voltage transformer. As I mentioned earlier, in order for the thermonic emission to occur, the temperature of the filament need to have at least 3 to 6 amps going through it for thermal emission to occur. So we have our KV meter on the primary circuit, and a meter located on the secondary side of the high voltage transformer. I could also say that the MA meter is located on the secondary circuit. The MA meter is located between the R transformer and the X-ray tube. High voltage transformer and the X-ray tube. I would say the MA meter is located between the step-up transformer and the X-ray tube. Okay, we have exposure timers, because there's different type of timers. The purpose of the timer, sometimes called a timer, allows the amount of electrons flow from the cathode to the anode at a specific time duration. The timer is generally located on the primary side of the high voltage transformer, same as the KV meter. In X-ray, the length of exposure time is usually a fraction of a second. And there's different timers have been built over the years in the imaging system. We can start from the least efficient to the most efficient. And because timing in X-ray is crucial, the timer circuit is usually an independent circuit compared to the other part of the X-ray imaging system. It's independent. It has an independent circuit. The timer circuit is going to located, again, I mentioned, in the primary side of the high volt transformer or Filament Circuit, or between the output transformer and the step structure. Okay, mechanical timer. Mechanical timer is used in a few projects, and it's pretty much disappearing with the gases. It works on a spring wound motor type. It's like an oven timer. You wind it up as the wind get down, the spring, and then make the exposure. The advantage of having a mechanical timer is that it's inexpensive to build or to purchase. The disadvantage of having a mechanical timer is that it's not as accurate as the other type of timer. You can only measure the mechanical timer down to as 1/4 of a second. You can't go lower than that. Some extra exposure don't need 1/4 of a second. You could go less than 1/4 of a second. Mechanical, you can go down to 1/4 of a second, 0.25 of a second. You can't time it less than 0.2 or 0.18. We have synchronous timer. This is more accurate than the mechanical timer. And the reason why I call it synchronous because it's based on the amount of hertz that's going through the system. Since the electric unit hertz, the electric cycle is 60 hertz. It's synchronized. It's timing based on 60 revolutions per second. Exactly how it works. Not quite know exactly how it works with that. But it works on synchronizations of the electricity coming in, which is 60 revolutions per second. And it's more accurate than mechanical timer because the minimum exposure time can go down as 1/60 of a second, which is 0.017 second, whereas mechanical can go down to 0.25 a second. And you could make it last as long as 20 seconds, which you don't really need. Most exposure, if you need to make the exposure longer, it's usually 1 or 2 seconds. The next 1 second is way too long anyway. And then we have electronic timer. This is the most accurate type of timer, the most complicated in terms of building it, so it's the most expensive. But the advantage of that is most accurate, and it's often used in the X-ray imaging system today. With the timing, you could go down to 1/1000th of a second. There's a timer. Okay. Type of electronic timer would be the milliampere second timer or the mass timer. The mass timer is an automation. The exposure will stop when the desired mass has attained based on your selection. And when you select like whatever mass it is, the computer will automatically adjust to the highest MA possible with the shortest exposure time. You don't know what the highest MA is because it's just automation. This mass timer is generally located on the secondary side of the high volt transformer, and it varies where it is, depending on the company. Modern X-ray imaging machine has mass timer, and it's made within what's called the falling load generator. for load generator purpose is to just automatically adjust to the highest MA at the shortest exposure time possible. Pretty much just redundant. Empty chairs.
I know, I noticed that.
Must be fantastic.
It's a killer or what?
Everything should be easy. Relatively, it's all relative. Okay, since there's a lot of combination between time X-ray exposure, the one formula you need to know for this unit is just milliampere times second to get mass, the amount of needed for your technique. So it's a very basic math. This is probably the hardest part of math. This formula. MA times second will give you mass. So let's do an example. Let's say there's a procedure, a KUB examination. KUB meaning that in X-ray you need to have the kidney, urea, and bladder in the film. In other words, it's just an abdomen X-ray. Requires the following techniques: 70 kV at 40 mass. If the technologists select 200 MA stations on the control console, what exposure time should be used? So, MA times second, kV mass. We know that our MA selection is
200.
time is unknown, and mass is 40, right?
Mhm.
Cross multiply. That's 4 divided by 20.
1/5 of a second.
0.2, right? 0.2 of a second. So you need, so this time selection will be 0.2. Simple. 0.2 a second, so what's that in millisecond?
200.
200 with decimal 3 times.
But it's always measured in seconds, right?
Everything's fraction of a second.
Yeah.
So, because X-ray everything's in fractions. One, rarely anything's 1/1 second. What's the fraction of a second?
1/5.
Any questions? Relatively simple, straightforward. Just be careful with the second, millisecond, point second. Let's go give you an example. Number 2, we have a technique called for 400 MA with 50 milliseconds exposure. What's your mass? MA is 400. Seconds 50. So we can move the decimal over to your base. So 1, 2, 3, so 0.05. Gives you 20 mass. So on your control console, it'll be 20 watts. Whatever KB selection you have. Any question? Questions? All right, and then here's another one with fraction. Give you all possible scenario. How much math would you generate if the control panel is set at 600 ampere with 1/30 of a second?